So the purpose of this lab, is we are going to be looking at and investigating and using velocity versus time graphs. Okay. Now, instead of actually running a lab where we collect all the data ourselves, okay, this one will go a little quicker. In fact, there's a pretty good chance you could get this done in class today if you were to stay focused on it, because I'm going to provide you with the data instead. So what we're going to be doing is comparing the acceleration data of a bunch of different cars that I have in the chart down below. Okay. So the problem we're investigating here is the change of a vehicle, change in velocity of a vehicle, measured over time, tells us acceleration. Okay. How can graphing help us calculate acceleration? Specifically, not just graphing, but how can a velocity versus time graph do that? Okay, that's what we're investigating here. And we've talked about that because last week we spent like 3 days looking at velocity versus time graphs. Okay, we talked about this formula and how it's related to this one for a velocity versus time graph. Spoiler alert, that might help you a little bit when you're putting your hypothesis together. Okay? All right, so for our variables, we're not actually performing this experiment, but here's how this experiment would have been run. Okay? Which variable, is going to go on the x-axis in this lab? Time. So what's your manipulated variable? Time. Okay? And kind of a similar reasoning to the position versus time graph lab. Okay? Time's a manipulated variable, okay, because if we're looking at a graph of time versus velocity, the longer I let the car accelerate, not the farther, well, yes, farther, but faster, right? It's the velocity. We're looking at velocity versus time here, right? So the longer I allow the car to accelerate, the faster it should go. Okay, therefore time affects velocity. Okay, which means then, of course, that since we're recording time and velocity, what's the responding variable? The other thing being recorded, right? Okay. Now, here's how the experiment was run to help you out with your control variables. On September 1st, we'll say, just picking a date at random. On September 1st, all of the cars in this chart were brought to the same place. And a single driver was told to accelerate them down an airport runway, one after the other. Which would have been a fun day looking at something. Okay? He was told, on this day, at this time, you will accelerate all of these cars down this very same runway, okay, for a total of however many seconds, or until you reach a speed of 45 meters per second. Okay. Yeah. From that data, okay, we're going to make these graphs. Everybody all right with that? Okay. All right, so for our hypothesis, okay, if data can be interpreted from a graph, okay, actually that's pretty vague. We're going to take that out. Okay, the if part needs to talk about what happens, what the relationship is between velocity and time for an object that is uniformly accelerating. Okay. So very similar to what you did in the last lab, except now we're talking about velocity and time instead of position and time. Actually, you know what? Let's say that a different way. Sorry. Something sounded better in my head. Okay. For the if part, I want you to define acceleration for me. Yes, better. Okay. So if, give me a definition of acceleration. Okay, so if acceleration is okay, the and part is simply going to be velocity and time data are recorded for several different cars as they travel down an airport runway or something like that. Okay, then then how will velocity be calculated from a velocity versus time graph? Okay, so very, very similar to what we had for our position versus time graph lab, except now it's velocity versus time. Now, here's where things are going to be a little different now from the position versus time graph lab. Okay? The way this data was collected doesn't set it up to actually work for putting all the cars on the same graph. Okay? We could do that with the position versus time data, okay, because the times were uniform. In this lab, that's actually not the way the data was recorded. Okay? Instead of recording the velocity every second, they actually recorded how long it took to reach certain velocities. So they recorded it differently, which means that this time you will have to create a separate graph for each car. Okay? It's actually not that much more work. You're entering the same amount of data, you're just doing it on 5 different sheets instead of one sheet. Okay? And the good news is that just like in the last lab, okay, the speeds are the same for every car. So you could just copy the speed column over from one sheet to the next. Okay? Everybody with me there? Now, which column needs to go first in Google Sheets when you build these graphs? Time. Because you want time on the x-axis. So you're going to pick 5 cars from this list. Okay? Whichever 5 you want. I don't care. Okay? You pick 5 cars from this list, and what you're going to do is you're going to enter their times in the first column, and then enter these speeds, 0, 13, 18, 22, 27, 31, 35, and 45. Okay? Put that in on that sheet, graph it for that car. Put the title on Lamborghini velocity versus time graph. Boom, done. Okay? Copy, go to the next sheet, so just click the plus button, add another sheet, make another graph for the next car. Everybody follow on that? Okay, so you're making a separate graph for each car, because you can't put these all in the same graph. It just gets really messy. Google Sheets get really confused, okay, when you try to do that. All right, so you're going to build those velocity versus time graphs, okay, and then not using slope is rise over run. Actually, I think I changed that in yours. Using the formula y equals m times x plus b, okay, you're going to calculate the change in velocity for each car. So you're basically filling in this chart, okay, for each car. Everybody follow me there? All right, so you'll have the car's name, you'll have the slope. Make sure you put units in here. All right, so on yours, okay, so in here, replace units with the actual units, okay, in your lab report. Okay, so what are the units going to be for slope on this graph? What are the units for B going to be on this graph? Okay, then I want you to rank them from the fastest accelerator to the slowest accelerator. Okay, and then lastly, you're going to be calculating their displacement while reaching 45 meters per second. And we went over how to do that exactly last week when I gave you a graph that looked like this. Actually, I gave you 2 of these. Okay, I said, okay, here's our graph. Okay, we need to calculate the displacement. There were 2 different shapes, all of that kind of stuff. Okay, so we need to make sure that we're doing that for each car from each car's graph. Everybody follow there? Okay, am I going to want to see your work? Yes. Okay, so for your analysis, okay, obviously analysis question number 1 is filling in the chart, but then don't forget 2 and 3. Okay, they're pretty simple. Okay, well, 3 is a lot of work, but it's fairly straightforward. Okay, for number 2, from your data, that is the slopes, which of your cars accelerated the fastest? I just want the name. Okay, and then for number 3, using your best fit line, calculate the displacement of each car in reaching 45 meters per second. Show your work for each car. Okay, everybody clear on the expectations there? Okay, then same as always, okay, you'll have your conclusion, okay, restate your hypothesis and explain whether it was correct or incorrect using your data. There's no evaluation here. Why not? We didn't do the lab. Okay? We weren't there when the measurements were taken. We have no idea what the sources of error might have been. So there's no evaluation here. Okay, it's a little bit shorter.
What's the difference between the displacement part of part 1 and then...
Nothing. It's just that's fill in that chart. Okay, so answering question number 3 is filling in the last column of the chart. Okay, I just want you to show your work. Otherwise, if I don't say this down here, show your work, people just fill this in. And then I have no idea what they did wrong by looking at the number. Okay. All right. So again, just a quick review here. Okay. Restate problem in your own words. Okay, you've got your variables. Each of them explained, manipulated explained, responding explained, 3 controlled explained. Okay, your hypothesis, definition of acceleration, description of experiment, how you calculate velocity using your graph. Okay, building 5 graphs. Okay, all inserted into your lab report, please. Okay, and then filling in this chart, and answering the analysis questions, and a conclusion. All right. Okay. If there are questions as you're going along, let me know. Okay. I'll actually, I think, just quickly walk through entering the data for the first car into the spreadsheet, just so you kind of see what I mean by what you need to do there. Okay, so when you're building this graph, okay, for our first sheet here, I'm just going to take the first car there. So I'm just going to call this sheet Ferrari. Okay, and then I'm going to put in this column here. This is going to be the time in seconds, and okay, I've got a time of 0, a time of 1.6 seconds, time of 2.1 seconds. 2.6 seconds, 3.7, 4.5, 5.7, and 7.9. Okay, so those are my times. And then this will be the velocity. And meters per second. Okay. 0, and then 13, 18, 22, 27, 31, 35, and 45. Okay, so then I can build my graph for the Ferrari from that. Now, I can copy this column over for every car. Okay, the velocity column is the same for every car. So I can save myself some work by simply copying that over, building a new sheet. Okay, so if this was for like a Corvette, let's say. Okay, I would put it here in column B simply by pasting it, save myself a lot of time. Okay, not having to re-enter those. I only have to enter the times then for each car. Okay, and then obviously the graph is the same as it was before. Okay, you highlight them all. Okay, insert your chart. Okay, put in your best fit line. Okay, same as before. So, your series. Okay, put in the trend line. Get the equation. Right, and you've got everything for each car. Okay, shouldn't take you very long, right? We got to build that graph in 2 minutes. So, how about it?